Am I audible? We were doing friction yesterday. We saw what is friction, its meaning. Then we saw friction force. We saw what are the factors that affect friction and how friction is harmful but also compulsory. Okay, and increasing and decreasing friction. Liquid friction also. Today we will do 15.4 exercises and we'll start with pressure. Okay, exercise 15.4. The force exerted against the motion of an object is known as the force exerted against the motion of an object is known as
Ma'am,
yes, Abraham.
friction force.
Friction. Yes, friction force. Okay, next one. To dash friction force, designs are made in tires. To dash friction force, designs are made in tires.
Ma'am, I can't see the question.
Can you see now?
To increase in friction force, designs are made in tires. Resistance of air is an example of air friction. Oiling is done in a machine to reduce friction. The two methods of reducing friction are number one is increasing the surface smoothness. We can do that by sanding, and also another method is using water.
Soiling and using water. How using water, Abraham?
Like suppose in a water slide, when the person is sliding down, there is water present in the slide to make it go fast. Or if you've ever gone to one of these water parks which are not that great, they're just in a hotel, sometimes you may find that you get stuck on the slide.
Mm-hmm.
So they use, but in actual one, like in bigger slides, they will use water coming out of the slide so that you won't get stuck in the slide.
Okay, that's correct, Abraham. Okay, that's correct. Even oil is used. Even oil is used to reduce friction. Okay, like for like different things, for different things, different substances are used. Sometimes they use, some people use soil. Water is used at some places. Oil is used at some places.
Now, oil is used mainly in machinery to reduce friction.
Yes, machinery to reduce friction, and powder is also used. Okay, in like games and all, such as carom board. Okay, so all of those things are used to reduce friction, pressure. Now, try to fix a nail in a wooden piece with head and tail. Now try to cut vegetable both with a blunt and sharp knife, which is easy. If we put the nail in the wall from the side of its head, okay, from the side of its head, then it will be very hard. Okay, but if we put it the side of its tail or from the pointed part, then it will be easy to put the nail in the wall. Okay, similarly, if you are cutting the vegetables with a sharp end, it will be cut easily, whereas with a blunt end, we'll not be able to cut it easily. We'll see why this happens. Okay. Do you feel that the area on which force is exerted, for example, on the tail part, makes work easy? Let's do an activity to understand the effect of force in the change of air. Take a wide utensil and place a thick layer of sand about 6 cm. Then take a brick. First, place its vertical and then horizontal. What do you find? The vertical shape of brick makes it go in depth. Okay, this is the vertical. Okay, this is the vertical. Okay, and this is the horizontal placement of the brick. Okay, in the vertical placement of the brick, when you place it in a vertical, that is a standing position, it goes deeper inside the sand. Okay, it gets deeper inside the sand compared to when you place it horizontal, it just goes on the surface of the land as it is like this. But doing it vertical, it goes in, okay, in the soil, in the sand. Now, the reason is the less area, which makes brick taking less contact to sand. The weight of brick and the effect of pressure increases in the second situation. The contact area of the brick and sand is bigger. Okay, so now what happens is that when in the second one, okay, in the second one, the because the surface area is lesser, okay, the surface area of the brick is lesser, it um, increases the pressure, okay, the pressure is more, okay, because its surface area is lesser, the pressure on the another object, that is sand, it is applying is more. Because the pressure is more, okay, because the pressure is more, it tends to go in the sand by some inches, it tends to go inside the sand, because the surface area is less, the pressure will be more. But in the first condition, the surface area of the brick, that is this portion, this is the surface area. The surface area of the brick is more, the pressure will be less. Okay. First situation, surface area is more, pressure will be less. Whereas in the second situation, where surface area, that is this portion, surface area is less, the pressure will be more. Okay. This works in the opposite way. Same way when we are hammering a nail. Okay. The surface area of the nail, this side is less. This side, the surface area is lesser. So the pressure will be more. Okay. Which is why we are easily able to hammer when we have the pointed tip on the wall. Which is why the pointed tip easily we can hammer in the wall. Okay. Compared to this head area, because here the surface area is more, pressure will be less, due to which it will be hard for us to hammer the head in the wall. Okay, understood this effect? Okay. Now, Emma, can you turn on your video? Are you there, Emma? Emma, are you there? Now, if equal force is exerted, then area is less and effect of force is in height and more communicating. Any and more communicating area more leads to reduction of force. Let us understand the exertion of force in effect of communicating area. Take a wide utensil full of sand and place a horizontal brick in it. Now place one more brick on it. Let's see what happens. We find that the bowl having two bricks instead is more deep than the bowl having one brick. Okay. Which stage has more pressure on vertical bricks? The one having two bricks has more pressure. What do we conclude? The increased force on the same base has increased the effect of this force. If the area of contact is same and the area is changed of the applied force, then the effect of force changes. What does this mean? What does this mean? See, when more pressure or when more weight is added, okay, when more weight is added, what happens is that it sunk in more. Okay, it went deeper. In the first case, only one brick was added to the vertical brick. Okay, to the standing brick, only one brick was added. So it was only little submerged in the sand, only a little inside the sand. But in the second case, when they added two bricks, it went more inside. Okay, so what happens is that the increased force, okay, these are the bases. What are my bases? My vertical bricks. My vertical bricks are my bases, okay, and increased force on the same base has increased the effect of this force. This part where you can see it submerged, this is the effect of force. This is the effect of force. Okay, when you add more weight, okay, or pressure, it will increase the effect of force. This is the effect of force. Okay, so this is very simple. Okay, if the area of contact is same and the area is changed of the applied force, this is the area of contact. Okay, this is the area of contact and this is applied force. If the applied force increases, effect of force also increases. Okay? Effect of force also increases or changes. All the above activities prove that the effect of force on the contact area is proportional to the area of contact. Sorry. All the above activities prove that the effect of force on contact area is proportional to the area of force and non-proportional to the area of contact. This effect of force is known as pressure. Okay, means that the one thing is that the more force you will apply, okay, applied force, the more will be the effect of force. the more will be the effect of force. Okay, more force you applied force, the more it is there, the more will be the effect of force. Okay, but what it is proportional to, okay, what it is proportional to, okay, the more force will be applied, okay, force will be more, the lesser the surface area. Okay, lesser the surface area, more the force. Okay, see, surface area, lesser the surface area, lesser the surface area, oh sorry, lesser the surface area, more will be the force, okay, or pressure, and more surface area, lesser force. Okay, this is proportional. These two things are proportional. Okay, whereas it says that non-proportional is what? Non-proportional is this thing. If applied force is more, applied force is more, means the force that you're applying is more, then the effect of force will be more, will also be more. Effect of force will be more. If applied force is less, such as here the applied force, this is the applied force is less. So the effect, that is this part, this is the effect, is also less. Okay, when applied force is less, then the effect of force is also less. This thing is said to be non-proportional. Non-proportional. Okay, or heterogeneous ratio. Okay, this is known as non-proportional or heterogeneous ratio. Okay, understood, understood, understood this concept of force and pressure. Understood the concept of force and pressure.
So basically, when there's more force, the pressure is more, and but the surface area will say whether it will go down or will stay up.
Surface area will is same only, Abraham, but surface area has to do with the force that is applied, okay, or the pressure that is applied. If the surface area is more, okay, like I said, in the case of a nail, if you are pressing the nail from the smaller pointed edge on the wall and then hammering from the bigger head of the tail, on that you're hammering, it will go easily inside because the surface area is lesser and more force will be applied to it. But if you are hammering, if you are putting the head of the nail to the wall and then hammering from the on the pointed side, so it will not be easily pushed inside the wall. Okay, because the surface area is more and the force that is applied is less. Okay, so this is in proportion. What is the proportion here? One thing increases, one thing decreases. Okay, like surface area is lesser, force will be more. Surface area is more, force will be less. Whereas second thing, the more force you apply, the more will be the effect of force. The less force you apply, less will be the effect of force. That is known as heterogeneous ratio. Now, this whole concept where there is surface area, force, and effect of force, the complete concept is known as pressure. Okay, this effect of force that is there, this effect of force that is there, okay, is known as pressure. Okay, this effective force is known as pressure. Understood?
Yes, ma'am.
Okay. Now, because two things we considered here in force, that is, in pressure, that is force and surface area, or you can say area. The formula for pressure becomes force divided by area. Okay, force divided by area. Force we studied is measured in Newton. Okay, and area we know is measured in meter square. Okay, because force is measured in Newton and area is measured in meter square, our final formula becomes Newton divided by meter square. Pressure is equals to Newton divided by meter square. Okay, this is how you calculate the pressure. Okay, pressure is the effect of change by force exerted on the base of an object. Pressure is the effect of change by force which is exerted on the base of an object. On the base of an object, the change that it causes, the effect by which it causes this change, that effect is known as pressure. Okay, pressure on any base is dependent on the area of base and the length of force exerted. Okay, now in the brick, it will be dependent on the area, that is this thing. Okay, the area and the length of force exerted. Okay, length of force exerted, that is this thing. Okay, and the area and the length, this thing and this thing is the length of force exerted. Okay, on the object. Vertical force on surface area of an object is known as pressure. Vertical force on the surface area, that is, this is my surface. Okay, and any force is applied to it like this. Okay, this is my vertical force. Okay, so this thing will also be known as pressure. When you are applying vertical force to a surface area, it will be known as pressure. Now, when is pressure increased? When is pressure increased? When area of applied force is increased. Okay, not the surface area, not the surface area, but the area of applied force is increased. What is the area of applied force? This brick. Okay, this brick. When this brick, the quantity increases, the more pressure will be increased. Okay, when you apply more force, then pressure increases. Okay, when the area of applied force increases and when the area of object decreases. Area of object decreases. See, in this previous example, this was in the horizontal brick had more area, so less force, less pressure. But in the second one, when the vertical brick had lesser area, lesser surface area, so more pressure, more force was there. Okay, so this is the area of object. Area of object, when it is decreased, then the force and the pressure will be more, it will be increased. Okay, when area of the object is decreased. And when is pressure decreased? When area of applied force is decreased and area of object increased. Okay, so in this first one, we have only one brick. Okay, means that the force and pressure is lesser because we have applied force is less. Here, the applied force is less. Okay, so our force and our pressure will also be less. Okay, so by decreasing the applied force, we can decrease the pressure. Okay, we can decrease the pressure by decreasing the applied force and by increasing the surface area. Okay, when surface area is increased, pressure decreases. So by increasing the surface area also, we can decrease the pressure. Okay, this is how you can increase the pressure or decrease the pressure. Understood? Okay.
Yes,
Now,
ma'am.
now, what are the effects of pressure in
Ma'am, will any of this come in the test? Like you'll ask us to what is Newton? Like you give the area and then you want us and the pressure and then you want us to calculate how much of so you'll give the pressure and you'll give the the other part and you want us to calculate the surface area of the object. The
if I
force
give
you'll give the pressure and then you want us to calculate the other part of the object.
Mhm. If I give you the force and the area, the force and surface area, and I tell you calculate pressure, okay, will you
Ma'am,
be able?
yes, ma'am. But will that come in the test?
I didn't give it last time because we don't have any numericals. Okay, we just have it in theory. We just have the formula, but maybe I can give this time in the form of MCQ. Okay, in the form of an MCQ or a short question that your force or N is suppose anything 80 and your area is 8 meters square. So find the pressure. So you'll have to calculate the pressure. Okay, so I might give you, but the definition is important and formula you should know. Okay, what is pressure is very important. Okay, how to increase and decrease pressure is also very important, and this thing is very important. This thing is very important for you all to do. Okay, that when surface area decreases, force increases, and when surface area increases, force decreases. This is proportional, and the heterogeneous ratio also. Okay, it is, which is non-proportional. This thing is very important when you are doing pressure. Okay, so please do it. Then please do
Ma'am, can
how.
you just explain the heterogeneous ratio again?
Yes, heterogeneous ratio. The more the applied force, or when the applied force is increased, the effect of force also increases. Means that when the force that I'm applying here, the horizontal bricks over the vertical bricks, that is the two bricks that are there. Okay. When I increase that, that is my applied force that I'm applying. When I increase my applied force, then the pressure here at the bottom, the brick that is standing is going more inside the sand, is going more inside the sand. Okay. So this is the effect of pressure. This is the effect of pressure. If I'm applying more force, then more it will go inside. Say one more brick I added, two bricks are there, third brick I added. So from the bottom, the vertical brick will go more inside the sand. Okay, why? Because it is the effect of force. It is the effect of force that is happening at the bottom. Okay, if I reduce this, see the first one, only one brick is applied. Okay, applied force is lesser. Applied force is less because only one brick is used. So what happens is that the vertical brick is going lesser inside. The vertical brick goes less inside the sand. Okay, because the effect of pressure is less. Okay, because the force that you're applying is less, effect of pressure is also less. Here, the force that you are applying is more, the effect of force is also more. This is your heterogeneous ratio. okay, which is non-proportional. Means that one thing increases, the other thing increases, one thing decreases, the other decreases. Okay, the above one thing decreases, another increases, one thing increases, the other decreases. That is your surface area and force. Okay, understood?
Yes, ma'am.
Okay, so we will stop here for today. Tomorrow we will see what is the effect of pressure in real life and what is atmospheric pressure. Okay, we'll do that tomorrow. But today we'll stop here. Okay, 5 minutes break for y'all, and then we'll start with simple interest. Okay, let's begin.
Hi, ma'am. Good morning, ma'am.
Hi, Joshua. Good morning. Okay. Abraham, Emma, hope you all are there. In the previous class, we saw how to calculate the principal. Okay. How to calculate the principal. Today we will see how to calculate the rate and time. Okay. How to calculate the rate and time. I taught you the principal, right? Now, check this question out. Check this question out. At the rate of 8% annual, at the rate of 8% annual,
Ma'am, this is simple interest, right?
simple interest. How much period, after how much period, on rupees 1600, the interest will be interest will be rupees 120. See, in this question, I have the rate which is 8%. I have the principal which is 1600 rupees, and I have the interest which is 128 rupees. I have to find out the time period. Okay, the time period I have to find out. What I will do is I will do the formula of interest. Joshua, what is the formula of interest?
Ma'am,
Yes, Abraham.
is the answer 1?
1. Yes, Abraham, correct. Yes, Joshua, what is the formula of interest?
Is it that rate principal interest?
Say again.
Pardon, ma'am.
Can you repeat it?
Is it that rate principal interest thing?
Yes, Joshua. Okay. Divided by 100. Okay. Interest is equals to principal into rate into time divided by 100. Okay, this is the formula. Now we will put the values. Interest is how much? 128. Principal is how much? 1600. Rate is how much? 8. Time I don't know. Divided by 100. Divided by 100. Now this time I will take that side and 128 I will bring this side. Okay. So first it will come beneath and the reciprocal will happen. See, first it will come this side and then this whole thing will go up. Okay. How? And this time will come this side. Okay. How? See, first we have time is equals to 1600 into 8 upon 100 into 128. Then I said you will do reciprocal, which will make it 100 into 128 by 1600 into 8. Okay, now you cancel. Cancel. Okay, cancel. Then cancel. Eight ones and eight ones. Okay, everything is cutting. We will only be left with 1. So our time period is 1 year. Okay, 1 year. Time period is how much? 1 year. Understood?
Ma'am, I did it another way.
Okay, Abraham, how?
I multiplied 8 into 16,
Okay,
which gave me 128.
okay. And then you cancelled.
Then 128, it gave me 12800. Then I cancelled, then I multiplied 128 with 100 and then I cancelled both.
Okay. You can do it like that also, Abraham, okay? Not a problem. It is correct. Okay. Okay. Now, please write this down and once it's done, tell me. Okay. Let me know once you've written it.
Ma'am, can you give us a question like this?
Yes, Abraham, I'll give you a question like this. 1 minute. Okay. At 8% annual, after how much period will the interest be? Will the interest be 1920 1920. Okay, I have to erase it. Okay, shall I erase the whole screen and write down the question?
Yes, ma'am.
Done, ma'am.
Okay. Okay, I'm writing it down. At 8% annual simple interest, in how much period will the interest be 1920, 1920 on a sum of rupees 400? Principal is 400. Okay, please note that your principal is 400. Interest is 1920 and rate is 8%. 8%. Find out the time. One minute. Please solve and find out the answer.
Ma'am, is the answer 60 years?
Yes, Abraham, it is 60 years. Emma, are you there, Emma?
Yes, ma'am.
Can you keep your video on?
Ma'am, I'm just finishing the answer and I'm about to be finished.
Okay, finish it and turn on your video.
Ma'am, the answer
Ma'am,
60 years.
ma'am, I'm getting 60 years.
60 years. Yes, the answer is 60 years. We use the formula SI equals to P into R into T upon 100. Your SI is 1920, P is 108, T upon 100. Okay. This I have to bring this side and the T I will take that side and it will be a reciprocal. So T is equals to 100 into 1920 by 400 into 8. Okay.
Ma'am,
Yes, Abraham.
ma'am, this is not a ma'am. This scenario that a person will wait 60 years for 400 to become 1920 is not real, right?
No, Abraham. I think it's not real, and I also think that the principle is a misprint. The principal amount in this question is a misprint. Okay, it must have been 4,000 or 40,000. I think the principal must have been 4,000 or 40,000 because the answer at the back is totally different. Okay, 4% they are giving. Sorry, 4. I think the answer is 4 that they are giving, but the it is a misprint. Okay, because the principal is very less, very small, and the interest is bigger amount. So this is not a real scenario and maybe a misprint. But if with 400 we do, we get the answer 60 years only. Okay, 60 years only. So it is correct. The solution of yours is correct. Now we will see how to calculate the rate. Okay, how to calculate the rate. I'll show you. We did the principal. Okay, we did the time period. Now we will see how to calculate the rate amount. 1 minute. Okay, take a look at this question. I'm clearing the screen now. Do you want to write anything or shall I clear it?
Ma'am, I finished copying, ma'am.
Finished. Okay. At what rate at what rate of annual interest will rupees 500 be the interest on a sum of money on a sum of rupees 2,500 after 4 years. Means at what rate? If I'm getting 500 as interest on 2,500 after 4 years, So what will be the rate at which I'm getting 500 rupees interest on 2500 after 4 years? Okay. Principal is 2500. Interest is 500. Time is 4 years. You are finding out the rates. Same simple interest formula we will use. Okay. SI equals to principal into rate into time upon 100. Okay. So write it down. 500 equals to principal 2500 into time 4 divided by 100. Okay. You can take this to the other side.
Ma'am,
Yes, Abraham.
no, it's me, Joshua.
Oh, yes, Joshua.
It's in interest you wrote 5,000.
Oh, sorry, Joshua. It is 500. Mistakenly wrote 5,000. It is 500. Okay. Please make sure that your rate is in percent. That you write the rate in percent. Okay? Because
Okay, ma'am.
rate is always in percentage. Okay? This is how we calculate the rates. Please write this down and then I'll give you one question to try.
Okay, ma'am. Done, ma'am.
Done. Okay. Now, I'll give you one question to try out. Okay. And Joshua will tell me the answer. Okay. Now, at what annual rate at what annual rate of interest on a sum of money rupees 900 will the interest be rupees 324 in 9 years. In 9 years. My principal is 900. My interest is 324. My time is 9 years. Okay, Joshua will tell me what is my rate. Calculate and tell me what will be my rate. Joshua, is your video frozen for me? Joshua, can you hear me?
What did you say, ma'am?
I'm asking if Joshua is having a network issue. Okay, it's better now. Your video froze from my side.
Okay, ma'am.
Calculate and tell me. Okay, Joshua, are you getting the answer?
Almost done, ma'am. Almost.
Okay, 2 more minutes. Abraham, your maths paper in the 6th chapter, I haven't received it. Okay, you sent me, but that was of the 5th chapter that you sent me accidentally. My
Ma'am,
mistake.
can you just click the maths paper? Ma'am, can
Ma'am.
you just open the maths paper that I just sent you on personal chat, ma'am? Not in the Zoom meeting, ma'am, on WhatsApp. Just open it, ma'am, and you'll see a big 6.
A big what?
There, it's written 6th chapter. It doesn't show on the when you see it like this up front, but only when you click it, it shows 6.
Yes,
And ma'am,
Abraham. Sixth chapter is written. Okay, I opened it, Abraham, but the heading is sixth chapter, but the test is actually of the fifth chapter, Abraham.
Ma'am,
Yes, Joshua.
is the weight 10%?
10%? No, Joshua. Not 10%. Okay, not 10%. Solve it. I'm solving. You check where you want where it went wrong. Okay. SI equals to PRT by 100. My SI is 324 equals to 900 into R into 9 by 100. Okay. Then I will do R is equals to 324 into 100 divided by 900 into 9. Cancel the zeros. Okay. 324 by 18. Oh, sorry, by 81. Okay. Then you cancel. Rate is 4%. Okay. Rate is 4%. Now tell me, Joshua, did you understand?
Yes, ma'am. I think I understood. I'm not entirely sure.
Why? Check this question and see if there are any doubts. Go through the solution and see if there are any doubts and then write it down. Okay. Abraham, you sent me the text which heading was chapter 6, but it was actually the test of chapter 5. Monomial, binomial, trinomial. That was not in 6th chapter, that was in the 5th chapter. Okay. So I cross-checked it with the 5th chapter paper and the 6th chapter paper, and it was actually the 5th chapter paper.
Okay, ma'am. But ma'am, I remember doing the test, ma'am. That day only, ma'am. I'll just search for where it is and then I'll send it to you.
Okay. Search for it and send it to me. Okay. And okay, Joshua. Also, 10 p.m. 10 a.m. today, when I'll take your extra class, Abraham, please join on
Yes,
my
ma'am.
personal. I will send you. I will send you separate link. Okay.
Ma'am,
Because first class will start on at 10 a.m. So this link will be occupied, but I'll send you my personal link. Okay, a different link. So on that link you join. Okay.
ma'am,
Yeah, ma'am.
Yes, Joshua.
you're teaching Abraham home science?
No, not home science. I am teaching Abraham maths only, but some other topic is there. His some doubts from the test that he's going to have. Okay, but I'm teaching home science for secondary level. I'm teaching home science for secondary level. Okay,
Ma'am.
separately. Okay, that class is at 1 p.m. Home science.
Okay, ma'am.
Okay, now Abraham will see you at 10, and Joshua, Emma, you all I'll see you tomorrow. Okay, tomorrow homework for today is exercise 9.1. 9.1, we have all the similar questions that we tried out till now. Okay, please complete 9.1 for homework today. Okay.
Ma'am, can you post
Yes,
it on the group, ma'am?
yes, Joshua, I'll post it on the group. No problem.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay. Okay.
Okay, ma'am.
So, Abraham, how was your English test yesterday?
Ma'am, it was good. It was easy.
Okay. Okay, that's good. So maths is today, right, at 12 p.m.
Yes, ma'am.
Okay. So we'll meet at 10. I'll quickly explain you midterm splitting. Okay. Then you can do a revision before you give your test for the 12th at 12 of maths.
Okay, ma'am.
Okay then. I'll see you guys. Bye. Have a good day.
Bye,
Bye,
ma'am.
ma'am.
Thank you,
Thank
ma'am.